All right, we're doing a 6.3 area of regular polygons. We may have covered this in class already. I'm a little behind on my videos, but it's important for you guys to see this. Take it nice and slow. Regular polygons. To be a regular polygon, that means that we have to have all the sides are the same, they're all congruent, and also all the interior angles are congruent. That's the definition of what a regular polygon is. That's like a square. A square, all four sides are the same and all angles are 90 degrees. Okay, this hexagon, if I put a center of the polygon, let's talk about the center in quotation marks, then actually what we do is we actually draw a circle around the polygon. Again, it's called a circle. It goes on the outside of the polygon. Then the center of the polygon is also the center of the circle. And we know how to find centers of circles. So when we look at it this way, we can say from the center of the polygon to the point or vertex of the polygon, we can call that a radius. And since we have another one over here, we can call that a radius. And now we have what's called a central angle. We know how to find the measure of central angles of circles. For this one, we have 6 different central angles. And so we would say we take 360, full circle, and we divide it by how many sides there are, n. So the measure of this central angle is going to be 360 divided by how many sides there are, which in this case is 6, and therefore it's 60 degrees. Okay, now this one is called the apothem, not a possum, but an apothem. It's not from the center to a vertex, but from the center to the midpoint of the segment. It's called the apothem. We can use this value to find different area formulas and different things. So like here's one. The area of a regular polygon is 1/2 times the apothem times the perimeter of the shape. This is a very unique way of looking at area because generally it's like base times height and things. Well, this uses the perimeter and the apothem. So if we're looking at the interior angles of a convex n-gon, our description would be n minus 2 times 180. We discussed the central angle, but now we're talking about the interior angle. The interior angle is where the vertex takes place. Now, this is also discussing the sum of the measure of the interior angles. That means I'm not looking for a specific value. I'm not saying this angle is this big, but all of the interior angles are going to add up to be this value. So, for instance, for a square has 4 sides. Well, 4 minus 2 is 2. 2 times 180 is 360. And we know that a quadrilateral, all 4 angles have to add to 360. For a triangle, this would be 3 sides. So 3 minus 2 is 1. 1 times 180 is 180. And we know the angles of a triangle have to add to 180. Okay, so now if we look, instead of the interior, if we look at the exterior. Now we're looking at the exterior angles of a polygon that looks something like this. All of these angles are going to add up to be 360, no matter how many there are. If there was a dodecagon, 12-sided, then either way, all of the angles on the outside would still add up to be 360. Information is located on your cheat sheet right here. The sum of the exterior and the sum of the interior. Let's discuss this. If I have a quadrilateral, what would be the sum of the exterior angle? Again, it's always 360. It doesn't matter how many sides there are, it's always going to add to 360. So now if we look at the interior angles, our equation was n minus 2 times 180. Well, 4 minus 2 times 180 is 2 times 180 is 360. I'm going to go fast through this part. You guys can pause the video at the end. But either way, we just keep plugging in the numbers. 6 sides, 6 there, and solve it. Put an 8 there, and solve. Okay, we're going to keep using this equation over and over and over again. Now, if it's n-sided, then it's n minus 2 times 180. Get that filled into your note sheet. Pause the video if you have to. I'm going on. Right here, instead of now thinking about what they add up to be, since they always add up to 360, we can now find the exact value of an individual angle by taking that 360 and dividing it by how many angles there are, or how many sides there are. So in this octagon here, we have 8 sides. So we take 360 divided by 8 and get 45. That means that this exterior angle right here measures 45 degrees. So does this one, this one, this one. They all measure 45 degrees. Over here on this pentagon, it's got 5 sides. So we take 360 divided by 5 to get 72. That means the exterior angle right here is 72 degrees. Now, on this pentagon, if the exterior angle is 72, then that means the interior angle has to be a certain value as well. So since they form a linear pair, we can take 180 and subtract 72 to find the value. Okay, it's very important that we discuss right here. Let me pull up my paper for a second. Okay, that this angle here is the exterior angle. I'm going to put EXT. And this angle here is going to be the interior, INT. And they both together have to add up to equal 180. Okay. So remember that interior plus exterior has to equal 180. We're going to use that on the next slide a lot. So again, this is going to be a condensed version. We're going to bring all those formulas we just talked about. We're going to put it into one big spot right there. The number of sides, we call that N, number of sides. Number of measures of exterior, the sum of the measures of the exterior angles. Remember, exterior angle theorem said that they all add up to 360. The measure of each individual exterior angle is 360 divided by N. The measure of the sum of interior angles, they have to add up to be n minus 2 times 180. The measure of each individual interior angle is just going to be 180 minus the exterior. Remember how I said the exterior and the interior have to add to 180? Well, that means that this one has to be 180 minus that one. So this is the formula we use, but I would maybe draw on there little arrow off to the side of my paper saying, adds to equal 180 or something like that. If you have it on your sheet. Right, so now let's start doing some information. I have 12 sides, 360. It doesn't matter how many sides there are. It's going to be 360. It's going to be 360 here and 360 here. It doesn't matter. So now if I take this 360, I divide it by n, it gives me 360 over 12. Well, that's going to give me 30 degrees. Now we take that same 12 and we plug it in right here, and we say 12 minus 2 times 180. Well, 10 times 180, which is 1,800. And then now I'm going to take 180 minus this value here, because they have to add to 180. So 180 minus 30 gives me 150. Okay. Or you could look at it as what plus 30 equals 180, and it's 150 either way. So the idea is we need to find out what n is first, because all of these equations deal with n. But if I give you the measure of the exterior angle, we're going to work backwards to find out how many sides there are. My apologies. Okay. So we take 360 over n. That's the equation that it should be. It actually equals 36 over 1. So we can do some cross multiplication here. We can find out that 360 is equal to 36n. I divide by 36 to both sides, right? And I end up with n equals 10. All right, so if n equals 10, we just solved how to find out the amount of sides there are. I take 36, cross multiply, solve for n gives me n equals 10. You could also think about 360 divided by what equals 36. And if that's the case, then we have to say, well, it's 10. So since the next value is always 360, we don't really have to spend much time on that. Now that I know what my n value is, I can plug it in down here. And I can say 10 minus 2 is 8. So 8 times 180, that gives me 1440. Let's say the measure of each interior angle. Again, I'm taking 180 and I'm subtracting this value here. So 180 minus 36 gives me 144. My interior angle is 144. So, well, that was great for 36, but now I know this one's 120. Remember how we talked about how these two values have to add up to be 180? Well, what does this angle have to be? That one measures 120. Well, I got to take 180 minus something to equal 120. And if that's the case, then I can subtract 180 over, and negative x equals negative 60, or positive x equals positive 60. However you want to look at doing that. I prefer just thinking about it conceptually and think, hey, 120 plus 60 equals 180. Now that I've got the 60 here, I can go back to the same way I did it before, and I can cross multiply, and I can say 360 is equal to 60, and divide by 60, divide by 60, I end up with n is equal to, looks like it goes in there, is that 8 times? Let's see here. It's 6 times. I can do math. Math is hard. So I end up with 6 over here because 360 divided by 6 is 60. All right. Again, this one's always 360. It's the exterior angle. Now that this one's 60, I know my n value. I can just plug in my n value here. I can say 6 minus 2 is 4. 4 times 180 is 720. I'm done. So please get this chart filled in. Then work on your essential question. How do you find the missing angle measure in a convex polygon? Guess what? We just did it all up here. However you want to describe this process, solving for n, plugging n in, those types of things, is fine. So take a minute, work on that. Now we're going to go into the area of regular polygons, okay? I skipped over a bunch of notes. I'm bouncing all over the place. Just find the examples that we're working with, and it should be okay. Based on this picture, I can find the area of the triangle because it's an equilateral triangle. Okay, we talked about how the apothem in this picture, it's from the center to the midpoint right here. This is x. So that's kind of given to me in the picture, but it's also represented by this new triangle we created. It's a 60, 30, 90 triangle. That's a special right triangle. So if I call this value here x, then suddenly r, because of our 30, 60, 90 triangle rule, becomes as big as that. And then this one down here is half of this whole side length, or half of s, and it's going to be equal to x root 3. This is all based on the 30, 60, 90 triangles. Again, I don't want you to write notes on this. This is extra credit. You can if you'd like to. If I times both sides by 2, I'm going to end up with the full s length, the full side length, is going to be 2x root 3. Now we know the perimeter of this triangle is 3s. We just add up all the sides to get 3 sides. Now, if I take this s value and I substitute in my new information, and I get 3 times 2x root 3, that's substitution. Now, if I substitute in, I can distribute or simplify it. Now I know my perimeter is really represented by 6x root 3. Well, I know my a is in reality is just x, so I substitute my area of a polygon. I get my apothem as x. My perimeter is 6x root 3, and then I multiply my x in, and I cut the 6 in half, and I end up with 3x squared root 3 as my formula for the area of a regular triangle with x being represented by the apothem. So now all I need to know is the length of the apothem, and I can now find the area of the equilateral triangle. I use the formula we just created. Here is the area is equal to 3 times the apothem squared times root 3. So I just have to take my apothem length and plug it in. This one needs to be done in your notes. Example 6.11 needs to be done in your notes. It will be graded. So now I order of operations. I do the exponent first, and I end up with 9 times 3. Now I do the multiplication, and I end up with 27 root 3 feet squared. Don't forget your feet squared. All right. Now, if I take that example, that equation that we created for the apothem, and now I want to, instead of writing it out for the apothem, I want to know what it is just based on the side length. If I come through here and I say, all right, here's the area formula for a triangle. Well, in this case, my base is a side length. Okay, this is all from the diagram. My height in this triangle is just the apothem plus a radius. So I get x plus r. Now, r happens to be equal to 2x because of last problem. Remember how we had the 30, 60, 90 triangle? This was x, this was 2x. So now if I plug that in my equation, I have x plus 2x. Well, that's just 3x. My height is 3x, and my side length is 2x root 3. But what if I want to solve for x? Then I divide the 2 root 3 over, and I say x is equal to s over 2 root 3. I can now plug this back in, and my height, I'm going to move it up a little bit so you can see, my height formula is now 3 times s over 2 root 3, which gives me, just simplifying it, 3s over 2 root 3. Now I can plug this information into my area formula, 1/2 the base times the height. So I end up with 6 simplifying the expression to get 3 squared over 4 root 3. I have to rationalize the denominator. I multiply by root 3 over root 3, and I end up with 1/4 s squared root 3. This formula is the formula for the area of an equilateral triangle just based on the side length. Right here, the area of an equilateral triangle if the length of a side is 6 meters. I just found that formula, and all I need to do now is just take the 6 meters and plug it in. And I square it, and then I divide that by 4 or multiply it by 1/4, however you want to look at it. And I end up with 36 times 1/4 is 9 root 3 meters. Since we use meters, we have to use meters squared as our answer. Okay, so I went a little quick there. All you're going to need to use is this equation right here and be able to plug in the side length. What's important in that example. Now, if I go on to do the same process with the hexagon, all that seems to be interesting is it's tipped now. So now the 30, 60, 90 triangle, here's your 30-degree angle, here's your 60, and now we can go ahead and work the same process out. It's going to look very similar. I'm going to go fast because I didn't expect you to do this in the class. I just want you to watch. So I have the side opposite the 30-degree angle is x. Okay, it also happens to be half of a side length. So that means that a side length is 2x. And that means our radius is also 2x because it's the opposite of the 90-degree angle in our special 30, 60, 90 triangle representation. So the apothem is now x root 3 because it's part of the 30, 60, 90 triangle. So the perimeter is going to be 6s. We just added them all up. But s, in fact, equals 2x right here. So if I substitute that in, I end up with the perimeter is 12 times x. So if I take that perimeter information, I plug it into the formula of 1/2 apothem times the perimeter. My perimeter is 12x. My apothem is x root 3. If I multiply all that out, I end up with 6 times x squared root 3. So this is for the regular polygon. I've now found it with relationship to just x. Now, originally x was half of a side length. So if I use this formula, the half length of a side is 3 feet. Well, that's exactly what x represents, is the half of a side length. I plug the 3 in right there. I square it, multiply it by 6, and I end up with 54 root 3 feet squared, which is great. That's the area based on the half of a side length. Now, if I want to use that formula and find out what it is based on a whole side length, I can now go through here and say, well, in reality, x is just half of a side. So I multiply both sides by 2. There. We're going to go straight substitution. If I just take the x now and I plug in s over 2, that's what it really represents. I plug that in for x. Now I square s over 2, and I end up with s squared over 4 times 6. Well, I can reduce this down to be 3s squared over 2 root 3. This is my new formula. I've just taken the x and replaced it with what it really represents, half of a side length. And then I do the operation, and I end up with a new formula based completely on one side length. So for this example, now it doesn't say a half length, it says the full length of 6 meters. So I take that full side length and plug it into this formula, which will be on your cheat sheet, and you plug it in, you get 6. 6 squared is 36 times 3, 108, divide by 2, 54. However you want to reduce your fractions is fine. The really important part is that you understand that you get the same answer. The area is the same because the half length and the full length were the same amount. Half of 6 is 3. So however you reduce your fractions is fine. Those two examples are really what was important. Summarize what you learned in this section. Let me go ahead and quickly pull up some homework examples in geometry for 6.3. All right, so right here, you can see here on number 7. This is the equation we're using, and this is the side length. I have to plug that in there, and I end up with 1/4 times 2 squared root 3. So 2 squared is 4. 1/4 times 4 is just 1, so I have 1 root 3, and my unit was feet, so I put feet squared. Over here, same thing. I just plug in the 3 right there. 1/4 times 3 squared times root 3. Well, this is 9 times 1/4, which is just 9 over 4 root 3. My units was meters, so now it's meters squared. For the hexagon, same process. I'm going to do this for number 6. I take the 6, I plug it in right there, and I get 3 times 6 squared over 2 root 3. Well, 6 squared is 36, so I take 3 times 36 over 2. 3 times 36 is 108 over 2 root 3. 108 divided by 2 is 54, so it's 54 root 3 feet squared. That's my final answer. All right, so that gives you an idea for how to do those two parts of the homework. The back side of the homework is extra credit. I shouldn't really have to deal very much with these on the test for parallelograms. Remember your rules for 60-90 triangles, and you should be able to find the height if you can do 60-90 triangles still. Okay, up here at the top, we talked about the rules. We did this one in our notes. This is the exact same process we went through in our notes, just doing it on the homework. So remember your formulas, bring them over from your notes. That's why it says see notes right here, because those are in your notes. Some of these we've actually done in our notes. This one here, it says it's 179 degrees, which means that this angle here has to be just 1 degree, because 1 plus 179 makes 180. So if that's the case, then the amount of sides it should be, well, what's 360 divided by what is 1? 360. So my side length, I have 360 sides, which means the exterior angle of here is 360. That's 1. Then we do 360 minus 2 times 180. You can do the math on that one. That's going to be 358 times 180. Pop on a calculator, type that out. You'll be fine. Kind of a quick example on how to do those. That's basically it. That's 6.3 notes and a little bit of homework help. Make sure you get it filled in your notes because it's due Tuesday.